All right, let's look at a scenario, our first result we talked about in the previous video, where direct substitution gives us a real number. So let's consider the limit as x approaches 4 of x squared minus 8x plus 16 divided by x squared minus 9. Now, and I gave you this one for a reason, because it would be very easy. I think after you do all of the problems through 1.6 and you start getting in this habit of, okay, factor when you can factor, use the conjugate when you can use the conjugate, that sometimes you have to just remember that you need to actually check to see what the value 4 gives us when we substitute it in here. And if I do that, if I just kind of do this mentally here, if I put 4 into the numerator, that's going to be 16 minus 32 plus 16, that's 0. But if I put it into the denominator, I get 16 minus 9, which is 7. And so I don't get this indeterminate form of 0 over 0. I actually get an answer. So I can evaluate this limit using direct substitution. So let's plug 4 into the numerator. And let's plug 4 into the denominator. And we get the values we just said. The numerator is 0. The denominator is 7. And this is in the example to remind you that 0 divided by 7 is a number. It's 0. 0 can be in the numerator. You can divide 0 by another number that's not 0. You can't divide by 0, but 0 divided by 7 or 0 divided by any number besides 0 is 0. So don't forget that that is a viable answer when you evaluate a limit.